Hello students, this video is on how to make true shape of inclined surfaces using auxiliary projections. So let us start. So basically two types of auxiliary views are normally used: auxiliary top view and auxiliary front view. The auxiliary top view is drawn on auxiliary inclined plane and auxiliary front view is drawn on auxiliary vertical plane. So in addition to the two standard planes were VP and HP, we will be using two additional planes: auxiliary inclined plane, which is like this. So auxiliary inclined plane, or in short form it is also called as AIP. This plane is normal to VP and it makes some angle, say theta, with HP. Since it is normal to VP, so if it is viewed from this position of the arrow, then AIP looks like a line which is normally represented as x1 y1. So x1 y1 is a reference line, is the additional reference line that shows the AIP. So the angle between x1 y1 and xy is theta. Similarly, AVP is another type of auxiliary plane which is normal to horizontal plane, and it makes an angle alpha with a vertical plane. Again, if it is viewed from this direction of the arrow, then the AVP will look like a line, and that line is the reference line x1 y1, and x1 y1 is inclined at an angle alpha to the reference line xy. So AIP, that is auxiliary inclined plane, contains AV, and AVP, that is auxiliary vertical plane, contains AFV. So let us start by understanding how to get the auxiliary view of a point. Now in this case, let us consider a point P, which is in first quadrant. Point P is 10 mm above HP and 20 mm in front of VP. So we start with by drawing the front view and top view of this point P. So P dash is drawn 10 millimeters above XY line, and P is, the top view is 20 mm below XY line. Now the next step, we are interested in making the auxiliary top view of this point P. Now the first step for making auxiliary top view is that we first draw a reference line x1 y1 which represents the auxiliary inclined plane, since auxiliary inclined plane is going to contain the auxiliary top view. So we draw a reference line x1 y1 which represents the AIP at a suitable distance from P dash. Now this line, this x1 y1 line, has to be drawn at some angle or some inclination. So this inclination will either be normally given to you, or there will be some concept or rule to be followed that we'll discuss in the following slides. So for the time being, you can assume that you know this inclination here. So we know x1 y1 at a suitable distance from P dash at a given inclination. So the next step is that we draw a projection line from this point P dash here onto this reference line x1 y1. This is very critical step in auxiliary projections, that you should make sure that all the projections that you make onto this x1 y1 line, all the projections you drop on this line, they have to be normal to this. Even that is true for any reference line, because you can see in this case also the line joining point P dash to point P here, this projection line is also normal to the reference line x here. So likewise in this case, whatever projection lines you drop onto x1 y1, all those projection lines need to be normal here. Now next step is that you extend this projection line beyond x1 y1 through certain distance. Now this distance is same as the distance of the top view from a reference line xy. So this point that we get here by extending this normal projection line through a distance of 20 mm beyond x1 y1, this point here is called as the auxiliary top view, that is ATV of point P, and it is represented as P1. So the key thing to be kept in mind is that the distance of the top view P from its reference line xy is same as the distance of auxiliary top view ATV from, that is P1, from its own reference line x1 y1. So the distance of top view from xy and distance of auxiliary top view from x1 y1 is same. To make the auxiliary front view of this point P on an AVP, so the first step is that we draw line x1 y1 which represents the auxiliary vertical plane AVP. Again, the angle of inclination of x1 y1 with respect to xy shall be given in the problem, right? So this angle of inclination shall be given, otherwise there will be some rule that we will discuss in the next slide, by which you can draw this line at a given inclination. So next step is that we drop a perpendicular projection line from the top view point, that is small p. This line is dropped onto the reference line x1 y1, and then we extend this projection line beyond this reference line xy through certain distance, which is 10 in this case, to get this point here. This point is called as the AFV, the auxiliary front view of point P, and it is normally represented as P1 dash. So the important takeaway is that the distance of the auxiliary front view P1 dash from x1 y1 is same as the distance of the front view P dash from xy. So the steps that we discussed for making the auxiliary top view and auxiliary front view can be summed up, and you can pause the video to note down these steps for your reference. Now let us apply the concept of auxiliary projections for getting the true shape of a surface. Consider this object. Now this object is placed like this in the first quadrant. So you can see that the various surfaces will be shown when this object is viewed from different directions, as shown by these three arrows. So in the front view, when we are viewing from here, we will be able to see this surface. Similarly, from the top view, we will be able to see these two surfaces, this flat surface and this inclined surface. From the side view, we will be able to see this vertical surface and this inclined surface. So these are the three different views for the given object. Now in this case, if you look at the front, this surface, this gray colored surface here, is appearing in its true shape here. This is because this surface is parallel to the vertical plane. If a surface is parallel to the vertical plane, it means all the edges on that surface are also parallel to the vertical plane. Now we all know that any line or edge that is parallel to a projection plane, then its projection on that plane is its true length. So it means that all these lines that make this surface here, they are also parallel to the vertical plane. So it means the projection of all these lines, that is these projections here, for all these lines, these projections are the true lengths of these edges. So such a projection in which all the edges making a surface, they are present in their true lengths, like in this case all the edges making this surface, they are appearing in their true length. So this projection is called as the true shape of this surface. Similarly, if you look at this flat surface here in the top view, this flat surface is equal to HP. So in top view, this surface is appearing in its true shape. Likewise, in side view, this surface is parallel to the profile plane. So this surface will be appearing as its true shape in the side view. But what happens to this inclined surface, which is surface 1? This surface is not parallel to VP, it is not parallel to HP, it is not parallel to the profile plane. So this surface, although it appears here in the top view, it also appears here in the side view, but none of these two views gives the true shape of this surface, because this surface 1 is not parallel to HP and it is also not parallel to the profile plane. So the problem is that we don't have the true shape of this surface in any of the three standard views. Now the auxiliary projections can be used to find the true shape of such surfaces which do not appear in their true shapes in any of the standard views. So to get the shape of this inclined surface using auxiliary projections, we need to first understand what do we mean by the edge view of a surface. So the edge view of a surface is defined as that view in which any surface that we are considering that appears not as a surface but it appears as an edge. So you can see surface 1 in the front view, it appears as this line. However, the same surface 1 in top view appears as a rectangle, which is not its true shape as discussed earlier. Similarly, the same surface 1 also appears as in its apparent shape here in the side view. So this line here actually represents surface 1. So this line is called as edge view of surface 1. So the first step in the procedure is that we identify the edge view of the surface in the given orthographic views. So in this case, out of the orthographic views as discussed, this is the edge view of the surface 1, which is named here as ABCD for the sake of demonstration. So this surface ABCD appears as line A dash D dash, line up to line C dash B dash. So this line is actually surface ABCD, and in the top view the four vertices appear as ABCD. So that is the first step. So we identify the edge view of surface 1, and that happens to lie in front view in case. Then the next step is that we put a reference line x1 y1 parallel to this edge view. So this edge view is the surface 1 which is inclined, and we put this reference line at a suitable distance. This reference line represents an auxiliary plane, and this is parallel to this edge view. So next we draw the projection lines passing through these four vertices, that is A dash, B dash, C dash and D dash, normal to this reference line x1 y1. So these four reference and these four projection lines are shown here like this, and we, as told earlier, we have to make sure that these projection lines fall exactly normal to this reference line x1 y1, otherwise the results may be erroneous. And next step is, we start taking these points one by one. Let us start with point A. Now this is the projection line that has been dropped from A dash onto x1 y1. Now we extend the same projection line beyond x1 y1 through a distance L1. Now what is this L1? This L1 is this distance of point A here in the top view. this L1 is the distance of point A from xy. So the same distance needs to be taken beyond x1 y1 here. Same process can be done for point B also, because distance of B from xy is also same, that is L1. So we transfer these distances L1 here and L1 here along projections from A dash and projections from B dash, and these points are marked as A1 and B1. So A1 and B1 are the auxiliary top views of point A and B. Then the same process can be repeated for points C and D as well. So we extend this line, which is the projection of line C dash, we extend it beyond x1 y1 through this much distance. This distance is L1 plus 25, which is this distance here, the distance of point D as well as point C from xy. So this distance is L1 plus 25. So you get these 2 points here, which will be C1 and D1. So these 2 points are obtained by taking this offset distance same as this offset distance here, right? Now in this case we are talking of this L1, because this L1 is any suitable distance which the user may take while making the front view and top view. However, this distance of D from this reference line xy will be this dimension AD, which is 25 in this case, plus this user specific distance which a user may take. So this L1 plus this 25 is the offset distance for D and C. So this way we get point A1, B1, C1 and D1, and if we connect all these 4 points here, so this shape will be called as the true shape of surface ABCD, that is surface 1. In case you have any doubts or queries, then please post your queries to this email ID. Thanks for watching this video.